In this tutorial, we're going to look at the use of video in Unity. There's a couple of ways you can utilize video. You can use it to create things like projections or TV screens, something that's literally just playing a video on an object. You can also use it in a more kind of warped way by adding video as a rendered texture onto an object that's sort of organic or amorphous in form. You can also use 360 video as a skybox to create a piece of software in Unity that either is a 360 video viewer or is a kind of hybrid between 360 video and kind of computer generated graphics in the virtual space. So let me show you how to do each of those things. The first thing that I think we'll do is create a kind of TV out of this light cube that we just animated in the last tutorial. So even though we liked it as a glowing pink hover cube, we might like it even more as a glowing movie hover cube. So what I'm going to do is jump into my assets folder and create a videos folder, which I've already done. And so inside here, I need to have a couple of videos. I pulled these in. This one is a segment of a film that I made, and it's abstract. It looks like stripes. You can preview it down here. And I'm going to use that over on our new stalagmites and stalactites object that I grabbed for free from the asset store. And then I am going to use this video of the Muybridge horse, which I got from archive.org on here. So here's what we do with video. You can throw MP4s into your project folder. You may, in general, want to have them be shortish and lower resolution if you're going to use a lot of them. I mean, Unity can definitely handle a certain amount of high-res video, but if you're going to be putting like multiple videos into your scene, realize that like you don't need a 4K video to occupy this tiny little cube that's never going to take up the whole screen, you know, especially if you're using like high-res video as a skybox or something like that, that is taxing on a computer system. So I have very small kind of SD videos in here, and they're pretty short loops as well. So they'll run really nicely. And you're just going to have to test and see how much you can get away with it on your system and in your scene. But we're going to start by right-clicking in the hierarchy and create an empty object. And I'm going to call this Muybridge Video Player. And that should be a hint that the component that we're going to add to this thing is called video player. So a video player takes a source video clip, which is going to be our Muybridge clip. And then it has a couple of options. Play on awake, yes, we do want it to do that. Wait for first frame just means it's going to wait for Unity to actually render the first frame. This is sort of irrelevant for us, but it could be important if we need frame perfect reproduction of our video. The only one I'm going to change here is that by default it doesn't loop, but I want this to loop. And then there's other things you can do. If it's going to drop frames, how does it deal with that? You can change the playback speed, which can be really useful here. And then importantly, we want to think about what is this doing with this video. So we're going to have it, in this case, do a render texture. We're going to create a rendered texture, and that needs a target. So inside our videos folder, we can create a materials folder. And inside there, we're going to create a render texture. And instead of new render texture, I'm going to call this Muybridge render texture, because we're going to have more than one of these. And take a look at its inspector properties. It's going to be a 2D render texture, and because we have a 2D video here. And I'm going to make this, for my purposes, the same as my video, which is 640 by 480. All the rest of this I'm going to leave be for right now, and then I'm going to jump back to my video player, and this render texture is going to be the target texture. Then that material is going to become the texture for my cube. All right, let's play and see what we've got. Okay, cool. Now, what's fun about this is it exposes a reality of something that goes on in Unity that we didn't know until right now, at least in this tutorial. And that's what's going on under the hood or behind the scenes with these geometric primitives, they're called, you know, these cubes and things like that. So in 3D modeling, in terms of like texturing, all of these 3D objects have what are called UV maps, which is essentially like if you think of any 3D object as like a box that you could sort of origami unfold and flatten out to a piece of paper, that's what the texture is applied to. Well, the cubes that Unity makes as sort of placeholder primitive objects have their UVs mapped in such a way that that one side coming around here is upside down compared to all the rest of them. And this is just sort of a reality of Unity's cubes. So if you apply a tiling texture to a Unity cube, one of the sides is going to be upside down. And there is some like complicated ways of fixing that, but honestly, the reality is if you were doing something more complicated than this, you would probably be using someone's assets that have been made in a 3D modeling program, Maya or Blender or something like that. If you really just needed a cube that you wanted to change the UV mapping of, it could be done in something like Blender or Maya. But for my purposes, I'm gonna live with this. I'm cool with it. I'm not gonna fret. But what I am gonna fret over is I don't really like. I loved this pink coloring up until I put a kind of a black and white bluish monochrome video on. And if I want to pretend like this is the source of the color, this radiant light just isn't doing it for me anymore. So I'm going to change that real quick. Our point light is going to have to become something much more like the color of this Muybridge footage. Cool. So that looks a little more convincing to me. Next thing I'm going to do is the exact same process, but it's going to have a different effect because I'm going to put it on something that is not a cube. So again, create empty. This is going to be a Stripes video player, or I guess I should just call it what it's called. This is from a film called Every Feature Film dot dot dot. It has a long title, so I'm just gonna call it every feature video player, and this will have a video player attached to it. Its source is this every feature film excerpt. It's also going to loop. Then we're going to make a render texture. This one happens to be 854 by 480, an SD 16 by 9 frame. And so then the every feature render texture is going to become the material for each of these stalagmites. We hook up the render texture to the target texture, and then we test. And what I like about this is that it can be a sort of a cheat way of getting some sense of animation to an object. Especially if you use an abstracted video, right? Like this video is always going to look like flashing stripes, but then when it's stretched every which way around a more complicated geometric form, it has kind of visual impact that I think is interesting. So that that effect is maybe not for everyone, but it feels kind of wacky and magical to me, so I think that it's going to work really well for my scene. Incidentally, we're going to deal with the audio from these videos in another tutorial, so don't worry yet. If you've pulled a video in that has audio, and it's blasting while you're testing this stuff, that's totally normal, and we will fix it in the audio tutorial coming up. But if it's bugging you now, you can mute it here in the video player. Just remember that when you do get around to doing that audio tutorial, it's muted. So you'll want to unmute it, or you'll be like, why won't it play? So like, just in case it isn't clear, you can obviously use these render textures to make warped moving textures on objects. You can have these repeating textures on 3D objects, but if you really just want to make a TV screen, you can create a cube that you squish, you know, down to the size of a screen, or you can create a 3D object plane. And that plane is a one-sided object, so you have to find the actual side that is like, that has a texture. Like if we throw it, if we turn it this way, it's invisible, but if you turn it this way, so -90, then we've got a wall with no thickness, just one side. And then I'm going to shrink it down a little bit. It has no y-axis at all because it's got no width. But if I make this into a TV screen and just sort of hover it, I can throw that any of these render textures on it as well. And if it's rotated the wrong way, then we just gotta spin it around, I guess 180 here. This would be -270 there. There we go. So despite the fact that when it comes in, you'd think, oh, it's all uniform gray, there is like an up, down, left, and right to this. So once you put a texture that has a directionality on it, all of a sudden you see like how how it matters which way you rotate it. One thing you might have noticed now that we've made sort of a TV or a projection screen here is that while it's being lit by the blue point light that we attach to the cube, when you go in and watch, I kind of liked the way that this cube looked on its own. But when you see it as a screen, it makes me realize that's not actually creating its own light, right? It's not like a projection that's lit up or an LCD screen or anything like that. It's more like a moving painting on a wall or something. It's like a Harry Potter newspaper picture or something like that. And I think it works in the cube, but actually it'd probably look more like this with our flashlight, right? If it were really making light. Well, that has to do with our render texture. So the render texture by default essentially makes every frame of the video into the albedo for the material, right? It's basically using the video as a texture. But it's not using the video as an emission. And so what you have to do, this brings us back to our emissive materials tutorial. What you have to do is check emission, and then we're going to use the render texture, the Muybridge render texture, as the emission too. So we drag it to this little empty box next to the color. And now, ta-da, it's getting its light information from the color of the film too. So this will take a couple minutes to bake because now we've got lighting that is hitting our walls here. And you get to choose if this is going to be baked, which looks prettier and affects these surfaces. But you would have to have this object be static, which is fine for the plane, but not fine for the cube, right? Which needs to move because we animated it. So it's not going to, the cube is not going to send this light out because it's static, this emissive light. But the plane can, and we can make it either baked lighting, which will look a little prettier across the architecture, or it could be real-time lighting, which would have the advantage of probably kind of flickering, but be potentially more of a render cost in real-time play. And this is what the stalagmites look like if you add the render texture as the emission as well on them. Just ups the contrast and gives the sense that the whites are actually creating light, not just the color white on an object. But okay, anyway, so now you've got a TV screen, you've got a repeating cube, you've got a video that's wrapped around something that is unusual in shape, and then finally I want to show you the way that you set up a video that just either takes over the whole headset if you just wanted to make Unity be a 360 video player, or for our purposes probably more useful, ends up functioning as a skybox.